Hello kings and queens, welcome back to the channel. So in this video we are going to discuss about the unbalanced method from the Hungarian problem or the assignment problem. In the previous video we have saw the balanced problem. So in this video we are going to focus about the unbalanced problem. As I said in the previous video, if we want to check whether it is balanced or unbalanced, we have to check the number of rows and number of columns. If it is a balanced problem, the number of rows and the number of columns will be equal. If it is an unbalanced problem, the number of rows and the number of columns will not be equal. So if it is an unbalanced problem, we have to convert it to a balanced problem and we have to solve. So let's check whether it is a balanced or unbalanced problem. So let's see the number of rows and columns. So the number of rows are 1, 2, 3, 4, 5 and 6. So the number of rows are 6. So the number of columns are 1, 2, 3, 4 and 5. So the number of columns are 5. The number of rows is 6. The number of columns is 5, which is not equal. 6 is not equal to 5. So rows is not equal to column, which means it is an unbalanced problem. Now what we have to do is we have to convert it into a balanced method, and after that we have to solve the problem. So now we have 6 rows and 5 columns. So we have to add one dummy column if we want to convert it into a balanced problem. If the number of rows is 5 and if the number of columns is 6, means we have to add one dummy row, and after that we have to solve the problem. So the continuation of E is F. So this will be our dummy column. In dummy column, we'll write the values 0, 0, 0, 0, 0, 0. So the number of rows and the number of columns will be equal. So the number of rows is 6 and also the number of columns is also 6. Now what we have to do is we have to do the row minimization and column minimization. That is row reduction and column reduction. So in this row, the minimum value is 0. In this row, the minimum value is also 0. In this row, the minimum value is 0. In this also, the minimum value is 0. In this also, the minimum value is 0. Among 8, 14, 8, 12, 16 and 0, the minimum value is 0. So this will be our second matrix, that is a row reduction matrix. So we have to label the matrix as same in the question matrix. So 1, 2, 3, 4, 5 and 6. A, B, C, D, E and F. Now we have to deduct the rows with the minimum value. Now we have to do the row reduction, which means we have to deduct the minimum values. So 12 minus 0 is 12, 4 minus 0 is 4, 10 minus 0 is 10, 4 minus 0 is 4, 12 minus 0 is 12, 0 minus 0 is 0. So 4 minus 0 is 4, 10 minus 0 is 10, 16 minus 0 is 16, 14 minus 0 is 14, 14 minus 0 is 14 and 0 minus 0 is 0. 14 minus 0 is 14, 16 minus 0 is 16, 12 minus 0 is 12, 18 minus 0 is 18, 16 minus 0 is 16, 0 minus 0 is 0. So 18 minus 0 is 18, 6 minus 0 is 6, 16 minus 0 is 16, 18 minus 0 is 18, 14 minus 0 is 14, 0 minus 0 is 0. So 12 minus 0 is 12, 4 minus 0 is 4, 6 minus 0 is 6, 8 minus 0 is 8, 10 minus 0 is 10, 0 minus 0 is 0. So 8 minus 0 is 8. 14 minus 0 is 14, 8 minus 0 is 8, 12 minus 0 is 12, 16 minus 0 is 16 and 0 minus 0 is 0. So now what we have to do is we have to do the column reduction, which means we have to identify the least values in each column. Among 12, 4, 14, 18, 12, 8, the least value is 4. Among 4, 10, 16, 6, 4, 4, the least value is 4. You can mark this 4 or this 4. Anything is okay. Next, among 10, 16, 12, 16, 6 and 8, the least value is 6. Among 4, 14, 18, 18, 8 and 12, the least value is 4. Among 12, 14, 16, 14, 10 and 6, the least value is 10. So in this, the least value is 0. You can take any 0 into count. So the column minimization values are 4, 4, 6, 4, 10 and 0. Now we have to do the column reduction. It will be our new matrix, that is the column reduction. Now we have to deduct all the values in the matrix with the minimum column values. So 12 minus 4 is 8, and 4 minus 4 is 0, 14 minus 4 is 10, 18 minus 4 is 14, 12 minus 4 is 8, and 8 minus 4 is 4. Next 4 minus 4 is 0, 10 minus 4 is 6, 16 minus 4 is 12, 6 minus 4 is 2, 4 minus 4 is 0, 14 minus 4 is 10. And 10 minus 6 is 4, 16 minus 6 is 10, 12 minus 6 is 6, 16 minus 6 is 10, 6 minus 6 is 0, 8 minus 6 is 2. Next 4 minus 0 is 0, 14 minus 4 is 10, 18 minus 4 is 14, 18 minus 4 is 14, 8 minus 4 is 4, 12 minus 4 is 8. And 12 minus 10 is 2, 14 minus 10 is 4, 16 minus 10 is 6, 14 minus 10 is 4, 10 minus 10 is 0, 16 minus 10 is 6. So 0 minus 0, 0, everything will be 0 here. So this is 1, 2, 3, 4, 5 and 6. A, B, C, D, E and F. Now we have did the column reduction. Now what we have to do is we have to do with the row scanning and column scanning, which means we have to strike off all the zeros in column as well as in row. So the condition is in a row there should be a 1 0, in column there should be 1 0 if we want to strike it off. If we have more than 1 0, then we have to skip that particular row or particular column. So in this row we have 3 0, so let me skip this row. So in second row the minimum number of zeros is 2, so let me skip this row as well. So in the third row we just have 1 0, so I will mark that 0 and I will strike off that particular column, because this is the rules. So if we found 0 in the row, we have to deduct that column. If we found 0 in the column, we have to deduct that row. So now I have found 0 in the row, so I will deduct this particular column. Okay, in the next row we don't have 0. Among 14, 2, 10, 14, 4 we don't have 0. So in the next row among 8, 0, 0, 4, 0 we have 3 0. So we should skip this particular row. So in the next row we don't have, we have striked off it. Okay, we are done with the row scanning. Now we have to do with the column scanning. We have to check zeros in the column. So in the first column among 8, 0, 10, 14, 8 and 4 we have 1 0. So I will mark this 0. I have found 0 in the column, so I will deduct this row. So in the second column among 0, 12, 2, 0 and 10 we have 2 zeros, so I will skip this column. In the third column among 4, 6, 10, 0 and 2 I have got only 1 0, so I will mark this. I have found 0 in the column, so I will deduct that row. Okay, in the fourth column among 0, 14, 14, 8 I have 1 0, so I will mark that 0 and I will deduct that row. Okay, in the fifth column I don't have any 0 because I just have values like 6, 4 and 6, so I don't have 0 and the F column is striked off. Okay, if we want to get a optimum solution, the rule is the number of rows and the number of squares inside the matrix must be equal. The number of squares inside the matrix is 1, 2, 3 and 4 and the number of columns are 1, 2, 3, 4, 5 and 6, so which is not equal, which means we have to go with the other step. So the next step is we have to find the minimum value among the left out values. So the left out values are 10, 12, 6, 14, 6, 14, 2, 10, 14, 4, 4, 10, 2, 8 and 6. So among this value we have to find out the least value. So among this value the least values are 2. We have 2 in the both sides. We can select any 2. I will select this 2. Okay, now we have to deduct this 2 from the left out values and we have to add this 2 to the intersecting points in the matrix. Okay, so this will be our fourth matrix. Let me mark it. And this is A, B, C, D, E and F. Okay, so the least value in the left out cells is 2. So I have to add this to the intersecting points and I have to deduct with the left out values which is not affected by row and column scanning. So the intersecting point is this, because the horizontal line and vertical line have met each other. So this is the intersecting point and this is the intersecting point. So this 3 is the intersecting point. Okay, I have to add this 2 to the intersecting point. So 0 plus 2 is 2. So we have to deduct this 2 with the left out value. So the left out values are 10, 12, 6, 14, 6, 14, 2, 10, 14, 4, 4, 10, 2, 8 and 6. So I have to deduct this 2 with the left out values. We have left out values in the third row. So 10 minus 2 is 8. 12 minus 2 is 10. 6 minus 2 is 4. 14 minus 2 is 12. And 6 minus 2 is 4. Okay, so in the fourth row also we have left out values. So 14 minus 2 is 12. 2 minus 2 is 0. 10 minus 2 is 8. 14 minus 2 is 12. 4 minus 2 is 2. So in the sixth row also we have some left out values. So 4 minus 2 is 2. 10 minus 2 is 8. 2 minus 2 is 0. 8 minus 2 is 6. 6 minus 2 is 4. So the remaining values which is affected by whether it could be a horizontal line or a vertical line. So those values remains the same, like 8, 0, 4, 0, 2, 0, 6, 10, 10, 4 and 8, 0, 0, 4, 0. Here 1, 2 zeros and here 1, 0. So these are the values which is not affected by the horizontal and vertical line. Okay, so we will be writing that values as it is which is there in the previous matrix. So now again we have to do the row and column scanning. So in the first row we have 2 0, so I will skip this. In the second row I have just 1 0, so I will mark this 0. As I have found 0 in the row, I will strike off that particular column. So in the third row I just have 1 0. I will mark this 0 and I will strike off that particular column. Okay, in the fourth row I have 1 0, so I will mark that 0 and I will strike off that particular column. In the fifth row I have 2 0, so I will skip that. In the sixth row I just have 1 0, so I will mark that and I will strike off that column. Now we have to do with the column scanning. So this column is striked off, this is also striked off, C column is also striked off. So in D column, among 0, 10, 12, 12, 4 and 6, we have just 1 0. So I will mark that 0 and I will strike off that row. In the fifth column, among 4, 4, 2, 0, 4, I just have 1 0. So I will mark that 0 and I will strike off that particular row. So now we have to check the number of rows and also the number of squares to get a optimum solution. So the number of squares inside the matrix are 1, 2, 3, 4, 5 and 6. So the number of rows are 1, 2, 3, 4, 5 and 6. So the squares are equal to the rows, which means we have got a optimum solution. And finally we have to do the table, like we have to calculate which job is performed by which machine and at what time. So the first is job, the second is machine and the third is time. Okay, so first job is performed by the D machine. We have to see where we have marked the square. So the first job is performed by the D machine. So first job is performed by D machine. Second job is performed by the A machine because we have marked the 0 under A. So 2 is A. Third job is performed by the F machine because we have marked the square under F. And fourth job is performed by the B because we have marked the 0 under B. And fifth job is performed by E. We have marked the 0 under E, so it is performed by E. And sixth job is performed by the machine C. Now what we have to do is we have to calculate the time. So for that what we have to do is we have to see the question matrix. Okay, so the first job is performed by the D machine at the time 4. Okay, first job is performed by the D machine at the time 4. We have to see the values under the column. Okay, and the second job is performed by A. Second job is performed by A at the time 4. And third job is performed by the F machine. Third job is performed by the F machine under that time 0. Okay, and fourth job is performed by the B machine at the time 6. And fifth job is performed by the E machine at the time 10. So sixth job is performed by the C machine at the time 8. How we have to see is we have to see the intersecting point. So first job is performed by the D machine. So 1 and D intersects at the point 4. So 4. And second job is performed by the A machine. 2 and A intersects at the point 4. Okay, 4. And third job is performed by the F machine. So 3 and F intersects at the point 0. So the time is 0. And fourth job is performed by the B machine. So 4 and B intersects at the point 6. 4 and B intersects at the point B. So it is 6. And fifth job is performed by the E machine. Fifth job is performed by the E machine. So the intersecting point is 10. And sixth job is performed by the C machine. The intersecting point is 8. So we have to calculate the total hour for this. The minimum time is equals to, we have to add all the values. Okay. So 4 plus 0 plus 6 plus 10 plus 8, which is equals to 32 hours. So unbalanced problem is also a same like a balanced problem. The thing which we have to do is we have to add a dummy column or a dummy row. We have to check the number of rows and columns. As per that, we have to add a dummy column or a dummy row, and the rest procedure is same. I think you all like this video. If you like this video, do subscribe to Kingmakers and share this with your friends. Thank you all. Have a nice day.